Hello everyone, myself I am Saranya, working as an assistant professor in the Department of AIML in MLR Institute of Technology. Today I am going to discuss about the topic of transposition techniques and what are those types. So coming to the first slide, what is meant by the transposition techniques and what are those transposition techniques? So there are two types of techniques, one is rail fence technique and another one is row column transposition technique. So coming to the transposition techniques. So what is meant by the transposition techniques and what are those types? In the transposition techniques, it is an encryption method used to encrypt a message or any other information. Either the message or the information should be an encrypted format. So in this transposition techniques, we need to perform some sort of permutations applied on the plain text letters. Means we will perform some of the permutation process of the plain text letters. Thus of the technique is known as referred as transposition cipher. So of these two techniques, rail fence and row column transposition techniques, the most simplest method is the rail fence technique method. So there are two types of transposition techniques. One is rail fence technique and another one is row column transposition techniques. So coming to the first process of transposition techniques, that is nothing but an rail fence technique. This rail fence technique will take an plain text format, will write down as a sequence of diagonal format. So taking a sequence of diagonal format, we need to read as a sequence of rows. Means whatever we are getting the plain text as sequence of diagonals, we need to write down or we need to read the as a format of ciphertext in the process of sequence of rows format. So for example, here we can see as a MLR institution is best. I have taken the example to encipher, that is MLR institution is best with the depth of 2. So here the sender or the receiver can take the any example of with the using of 2 or any 3 or 4. So based on the questions, we need to solve the problem. So I have taken here the encipher of the message is MLR institution is best. So with the sequence of rows, how do we need to write that as a sequence of diagonals? So for this MLR institution is best, I need to solve the problem of depth equals to with the 2. So I am taking here as one rectangle box. So let us try an example of MLR institution is best. So while we are writing as sequence of diagonals, means already have started with the plain text process here, means it is an input process. So I am taking here as input process of the plain text. So while here discussing of the plain text, the input is MLR institution is best. So I am taking here M L R I N S T I T U T U T I O and N. With the also is and down of the format is best. So I didn't have enough space, so I am writing here with the best, means B, E, S and T. So we have written like this, means already the rail fence technique is defining as a sequence of diagonals and we need to read as the sequence of rows. So already we have taken as the input of the plain text, that is MLR institution is best. So we need to write down with the again of output of ciphertext. So already this is considered as row 1 and this is considered as row 2. So already while we are seeing with the diagonal, see here MLR institution is best. This is the output. So while we are writing as the ciphertext of the output, we need to write as the row 1 and row 2. So what we'll get here? Row 1 and row 2. In row 1, MRNT, again T, TOIB, and S. These are the row 1, we got the output of the ciphertext. The next LISI, UINS, E and T. These are the output of the row 2. The row 1 and row 2 are the output of ciphertext. Means we already written as in the sequence of diagonals and then read as the sequence of rows. That's why I have read as row 1 and row 2. This is the input and we got the output of the ciphertext, that is row 1 and row 2. This is the output of rail fence technique. For example, of any problem, we need to cipher the message. Of any words of the question, we need to write down as the depth of 2 or 3 based on the questions. Like that we need to, for example, if it is 3, we need to draw as an 3 of formats. So then we need to solve here. That is the process. Then rail fence technique is completed. Then second one is row column transposition techniques. In this row column transposition techniques, it is a very complex scheme while compared to the rail fence. Rail fence is very easy. Row column transposition is some more complex problem. And it also will be an rectangular format. While writing the row column transposition technique, we need to write row by row. While we are going to read column by column. Of all this forming a rectangular process, we need one key, that is nothing but an order of the column. So based on this order of the column, we are going to get an of the output of the ciphertext. Means already we are, for example, encrypting the message, the students are participating in events. So I have taken the example of students are participating in events. The main 5 points we need to remember is, it is a more complex problem and we should be written in the format of rectangle process. While we are writing, we need to write row by row. While we are reading or we need to get the output, we need to read as column by column. While we are taking the column by column process, we need to refer the process of key, that is nothing but an order of the column process. So let us take an example, that is students are participating in events. So I am taking here as students are participating in events. So this is the example. So I am taking an rectangular format, that is so. So let us take one example. First one is students. So students. So I am taking here the 7 columns. So I am taking here as 7 columns. So whatever we are wish, that is will be an 5 rows 7 columns, 5 rows 7 columns, or 6 rows 8 columns, or maybe 3 rows 5 columns. So based on the question will be there, how do we need to divide, or our wish. For example, if it is the lengthy of the example, we will get the some more columns and more of the extra rows. So already I am writing here the rows format. We need to write in the row format only. We need to write in the row by row. So I am taking here the row by row format. So STUDENT. Then after here the remaining word of S. So I am writing in the next row S. The next one is RARE. The next one is participating. PARTICIPATING. Next one is letter in. In. The next word events. Continuation. EVENTS. Then what about the remaining of these 3 places? So what we have done in the Caesar cipher or the Playfight cipher, whatever the we are remaining getting of the remaining letters, we are going to add some of the bogus letters. So I am adding here the bogus letters of 3 letters X, Y and Z. So these are the 5 rows and the 7 columns. So I have written here 5 rows and 5 columns. So I got the 5 rows, that is row 1, row 2, row 3, row 4, row 5. So there are 7 columns. So after this 7 columns and 5 rows, we need to initiate one of the key. Means we need to format of any one of the key. So I am taking here key as 4, 3, 2, 1, 5, 7, 6. So I am taking here the order of key 4, 3, 2, 1, 5, 7, 6. Total 7 columns. So I am writing here 4, 3, 2, 1, 5, 7 and 6. So we got the from 1 to 7 columns. So how we are going to get the output of the ciphertext? So here see what is the ciphertext? The ciphertext will be the 4th column is considered as an first column. The next 3rd column is considered as an second column. Second column is considered as an 3rd column. First column is referred as an 4th column. And 5th column is referred as an 5th column. Last 7th column is considered as an 6th column. And 6th column is considered as an 7th column. Then see how is the output will be get. Then what here the first of the output of the ciphertext means we need to consider what we have written here. We need to read column by column. So already we have written in the format of the row by row process. While we are reading, we need to read by column process. So I am taking the here of the, we will get the output of the ciphertext is column by column process. So here the ciphertext is first column. Thus you see here the first column is DEIIIS. DEIIIS. So first column is completed. The next second column U, R, C, G and T. This is the second column. The next third column T, A, I, N, N. The next fourth column S, S, T, I, E. The next fifth column E, P, P, N, X. The next sixth column T, R, T, V, Z. The next seventh one N, A, AEY. So this is the ciphertext. I got the ciphertext of from 1 to 7 columns. I got the output of the ciphertext. Means it is an somewhat complex. If the problem should be some more complex, the taking as input of ciphertext and acting as again to the plain text. Means we are taking this output of the ciphertext as input of the plain text. Let us see what will happen while we are taking the ciphertext of this letter. This all letter, what will happen? So what is the ciphertext of? Ciphertext of D, E, I, S, U, R, C, G, T, T, A, I, N, S, S, T, I, E, double P, N, X, T, R, T, V, T, R, T, V, Z, N, double A, E, Y. Z, N, double A, E, Y. These are the input of the ciphertext. So already have taken is the ciphertext. Now I am going to say this considered as an some more complex means what we need to do. So this is an input. By doing the same process, we need to create one tabular format, that is 5 rows and 7 columns. That is D, E, I, S, U, R. 4, 5, 6, 7. 7 columns, and C, G, T, T, A, I, N, S, T, I, E, P, N, X, T, R, T, V, Z, N, double A, and E, and Y. By solving this, we will get one more example of the ciphertext. Means by using the same process of 5 rows and 5 columns. So already we have getting the R1, R2, R3, R4 and R5. Means while we are writing the exam of the row column transposition, they are giving one of the sentence. If there is not complex, we will get an answer of the ciphertext. For example, if it is more complex like this of these letters, for example, they are going to ask any of the words or any of the letters with the some of this plain text like this, we need to solve the problem like this. That is the ciphertext. What we need to numbering here, I am giving the 4, 5, 2, 1, 6, 7 and 3. I have changed the format of the key. So what is the key here? 4, 5, 2, 1, 6, 7, 3. This is the format. So here fourth column is considered as the first. So what is the first one? I, T, X, A. Second one, I, T, S, N. Next third one is R, N, E, T, Y. The next fourth one, D, C, N, P, V. The next one, fifth one, E, G, S, P, Z. The next sixth one, S, A, I, T, A. The next seventh one, U, I, E, R, E. This is the ciphertext process. This is the ciphertext process of the row column transposition. That what we have said here. That it should be an rectangular format, and while we are reading, it should be an row by row. While we are reading as column by column. But the order will be an any of the order of the column while we are taking. This is the example which the problem should be more complex. So, in today's session, we have discussed the types of the transposition techniques with the relevance of one of the example, and row column transposition technique is also one example we have seen. In the next session, we are going to discuss next two topics of digital signature and authentication protocol formats. Thank you.